In this lecture, we'll be seeing some introductory concepts of Markov chain analysis. We'll be directly jumping on to the problem, and with the help of that problem, we'll try to understand what Markov chain analysis is. So here we go on to the problem. Mm, so say there are three mobile service providers A, B, and C competing for maximizing their share in a fixed market. Fixed market means the market in which the number of customers are fixed. No one adds to the market and no one leaves the market. For example, in the market with which we are concerned, there are 1,000 customers and they will continue to be 1,000, right? Due to various courses of action used by these companies, customers keep on switching the brands from one provider to another. For example, A users will switch to B, B will switch to C, and so on, or vice versa. Following is the composition of the customers at the beginning of January 2019 and at the beginning of January 2020, right? So there are three mobile service provider companies A, B, and C. At the customers as on 1st January 2019 are 500 customers of A, 300 of B, and 200 of C. And when the data was collected once again on 1st January 2020, it was found that there are 400 customers of mobile service provider A, 200 users of B, and 400 users of C. Now, when the data is further drilled down, the change from 500 to 400 as far as mobile users, mobile service provider A company is concerned, it might be or is because of some gain from other companies and losses of losing the customer to other company. But that details are given below. Okay, so first column again, company A, B, and C customers as on 1st January 2019, those are 500, 300, and 200. Now, what has happened during the year? Company A has not gained anything from A, right? It has gained 50 customers. 50 customers of B company A has gained, and 50 customers of company C A has gained. Okay, so A has gained 50 and 50 from B and C, but simultaneously there was a loss of some customers from A to B and C, and that was A lost 100 customers to B and 100 customers to C. So there is total loss of 200 and gain of 100. Resultantly, the number of customers of company A are reduced down to 400. Similar things happen to B. Okay, B had on 1st January 2019 300 customers and 100 customers it has gained over the year from A, and 50 it has gained from C. But simultaneously, there was loss of 50 customers to A. 50 customers of B switched their loyalty, switched to company A, and 50 users of B switched to use mobile service provided by C, right? So total loss is 250 and gain is 150, so net loss is 100. So therefore the customers of B drop down to 200 from 300. Okay, as far as C is concerned, there were initially 200 customers and 100 it has gained from A and 200 it had gained from B, whereas in the same period 50 it has lost to A and 50 it has lost to B, right? So if I count the total gain to company C, it is 300 and the loss is 100. 50 plus 50, 100. Okay, so net gain is of 300 minus 100 means 200. So therefore, the number of customers of mobile provider C is rising from 200 to 400. So so it is because of gains from some company, A or B or C, and losses to A, B, and C. The final composition of the customers is like this. Now we'll be using this information. This information is somewhere here, like 50-50, BC. Company A is losing 50 customers to B and 50 customers to C. That means company B is gaining 50 customers from A and 50 customers from C. So what we'll be doing, this piece of information we will be now focusing on, right? So here we will be writing whole the dynamics which is occurring as far as brand switching between ABC companies is concerned. Here we are trying to write that in a matrix form. Here companies ABC, here companies ABC. Now in this direction we are writing retention and losses too, and in this direction we are writing retention and gains from. That will get us the complete information we are thinking up. Like company A is losing 100 customers to B and 100 customers to C. Okay, initially there were 500 customers with A, out of which 100 had been lost to B and 100 had been lost to C. It means that 300 are retained by A, right? 300 are retained and 100 are lost to B and 100 are lost to C. Now let us see what happens with B company during 1st January 2019 to 1st January 2020. 50 customers B has lost to A and 200 customers B has lost to C. Total number of customers B was having at 1st January 2019 was 300. So out of that, 50 it has lost to A and 200 it has lost to C, means 250 lost and 50 retained. Therefore 50 are retained, right? That is whole the breakup of 300. Now company C was having 200 customers. Now, what happened with the 200 customers? 50 lost to A, 50 lost to B, and total loss is 100. That means 100 is retained by company C. Okay, now whole the dynamics, what is happening with each company as far as brand switching is concerned are state changing. We will be saying that these are the states to begin with and these are the states to get converted to, right? A may change to A may change to B, A may change to C, or state B may change to A or B or C, or likewise state C may change to A or B or C. So it is the brand switching or state switching mechanism we are concerned with, right? Now we know that there were 500 customers of A, 300 customers of B, and 200 customers of C. Now, this is the dynamics of switching going on in between various companies. We'll put this dynamics in form of probability. This is called as transition matrix. Okay, now we'll be converting this to transition probability matrix. So out of 500, 300 are retained, means retention probability is 3 by 5. Okay, probability that the customers of A will lose to B is 100 by 500 because total number of customers is 500. So 100 by 500 probability will be 1 by 5. Likewise, the customers of A losing to C, what is the probability? 100 by 500 again, that means 1 by 5. Now, total number of customers of B was how much? It was 300. So what we'll be doing, we'll be dividing each of the quantity in this row by 300. So 50 by 300 will be 1 by 6, 50 by 300 again 1 by 6, and 200 by 300 will be 2 by 3. Here I have written it 4 by 6, so that you come to know something specific here that will be seen later. Now, total number of customers of C. If you do not know, you simply make the sum of this. That were the total number of customers of C. How many? There were 200 customers, right, to begin with at 1st January 2019. Okay, now the probability of switching, probability that the customers of C will switch to A is 50 by 200, that is 1 by 4. Again, probability that the customers of C will be switching to B is 50 by 200 again, so therefore it is 1 by 4. And probability that the customers of C will be switching to C means retaining with C, that is 100 by 200, that means 1 by 2, that means 2 by 4. Intentionally the denominator is kept same, like here 3 by 5, 1 by 5, 1 by 5. That's not much mandatory, but one thing will click to you, that sum of all the probabilities here in the row is 1. 3 by 5 plus 1 by 5 plus 1 by 5, that 5 by 5, 1. Likewise here the sum is 1, likewise here also the sum is 1. So one thing must be borne in mind, that the sum in the row must be 1. Okay, that may not be 1 in the columns. Okay, but for having the valid transition probability matrix, the sum of all the probabilities in written in a row must come 1 for every row. Now, this transition probability matrix is giving you the way transition is occurring from these three companies to these three companies. So, this is a great tool available to us to let us know what is going to be the market composition of company A, B, and C at the end of 1 year. This transition probability matrix is valid on annual basis. So period is very important here, because the transition may occur over a period of a year, or maybe sometimes over a period of month, or weekly, or biannually, or quarterly. Okay, so once you get hold of what is the period after which definite transition occurs in a definite pattern, that will help you in predicting what is going to be the market composition or state composition after that period. So here we knew that this is the market composition on 1st January 2019. Okay, what I am going to do, this market composition, I will process it by this transition probability matrix to get what will be the market composition of companies A, B, and C. So here we know that out of 500 customers of A, 3/5 of the customers out of 500 will be retained with A, and 1/6 of 300 customers of B will be gained by company A from B, right? And 1/4 of the customers of C. How many customers of C were there? 200. So 1/4 of 200, that is 50 customers, will be gained by company A. Okay, these figures are talking about gains by A. Okay, these figures are talking about, in a column they are talking about gains by B. These figures are talking about gains by company C from A, from B, and from C itself. All right. So once we have understood what is this transition probability mechanism, we simply can multiply the market share by the transition probability matrix to get the new market share. You have well understood the mechanism. 3/5 of 500 are retained with A. 3/5 of 500 means 300 are retained with A. right? One sixth of 300 customers of B, that means 50 customers of B are attracted by A. So total count now 300 plus 50, 50, 350. Then, furthermore, one fourth of 200 customers of C are attracted by A. That is 50 again added to 350. That will make it 400. All in all, mathematically saying, this multiplied by this will give you the market share or market composition or the number of customers of B at January 20, 1st January 20, after 1 year, right? 300 multiplied by 1 by 5, the 300 by 5 plus 300 by 6, sorry, 500 into 1 by 5, that is 100, plus 300 into 1 by 6, that is 50, then 200 into 1 by 4, that is again 50, so total comes out to be 200. Likewise, 200 into 1 by, sorry, 500 into 1 by 5 plus 300 into 4 by 6 plus 200 into 2 by 4, the total comes out to be 400. So this is the market share which was given to us directly in the problem. If you look back, this were the market composition at 1st January 2020. Now, what is not given is the market composition customers as on 1st January 2021. Can we find it out? Yes, we can. What we will have to do, you start with this market composition of companies A, B and C multiplied by same transition probability matrix will give you the new market composition. Okay, again this multiplied by this is the market share at January 20, and by multiplying it by transition probability matrix, in short called as TPM, will give you the market shares on January 21. Likewise, if you multiply these market shares by transition probability matrix again, you will get market shares at January 2022, like we have got here. These are the market shares at January 21. We have multiplied that with the transition probability matrix, and here we have got the market shares at 1st of January 2022. Now, this process can continue further, but one thing we are finding that as far as company A is concerned, the market share is dropping from 500 to 400, 400 to 373.33 to further 362.88, and it will continue to drop but will not go to zero. Simultaneously, if you look at company B, the market share is increasing from 200 to 213. So from 300, sorry, it is decreasing from 300 to 200 to 13.33 to 13.55. Likewise, company C in at 19 January, 1st January 19, it was 200, then it increased to 400, then 413, then sorry, 423.55. Now, this market shares of A and B are dropping and company C is increasing. Okay, this is the transition process going on, and it will stabilize at certain point, and the steady state will be reached. You understand? Steady state will be reached. And what is steady state? Steady state is the state that even after undergoing this market share undergoing the transition, it remains the same. Okay. So these are the market shares. You are observing that they are changing. They have changed in last 4 years, and they will continue to change. And a stage will come whereafter it won't change. So what you will be asked, what will be the steady state market share? So what you will have to do for that, you take certain variable. X is the market share of A, Y is the market share of B, and Z is the market share of C. You can take it as x1, x2, x3. Now taken them as x, y, z. Multiplied by transition probability matrix will give you same market shares like X, Y, and Z market shares of company A, B, and C respectively. So this is going to give you three equations. But unfortunately, these three equations together cannot give you the value of x, y, and z. Why? Because if you simplify these equations, you will find that all the equations have their right hand side equal to 0. Okay, having right hand side for all the equations equal to 0 makes it difficult for you to get the values of x, y, and z. They do not get solved, so you need to have one equation which doesn't have a right hand side equal to 0. Okay, I will just demonstrate one equation to you. It is 3 by 5x plus 1 by 6y plus 1 by 4z equal to x. And if I bring that x to this side, what will happen? The equation will become minus 2 by 5x plus 1 by 6y plus 1 by 4z equal to 0. And same thing will happen with another equations. Every equations coming from this expression, this set of equation will have right hand side equal to 0. Okay, so as I said that you need at least one equation which doesn't have right hand side 0, and you have one equation. Sum of all this will always be equal to total market, total number of customers. Okay, so x plus y plus z is equal to 1000. Here if you do the sum, here if you do the sum, wherever you do the sum, you will find that it is coming out to be sorry, it is coming out to be 1000 everywhere. 400 plus 200 plus 400, 500 plus 300 plus 200, and this also comes 1000. So we have one equation, x plus y plus z equal to 1000. Now you may eliminate one equation out of these three equations, but essentially add this equation. Consider this equation always, because this has non-zero right hand side, and these three equations will be having zero right hand side. So you may eliminate any one of the equation. Okay, because you need just three equations. One is this, and this is going to give you three. You just consider two out of those. So you finally will be having three equations, after solving which you will be getting x equal to 357.14, y equal to 214.28, and z equal to 428.57. This is going to be the market share. Now, one thing you must have come to know, that is your steady state market share is the function of transition probability matrix only. Once you know your transition probability matrix, you know this steady state market share, because this you can, if suppose say you do not know the total number of customers, you can always take x plus y plus z equal to 1. Okay, where x, y, and z are the proportions of the customers of A, B, and C. So this equation is always going to be there. Right now here it is in the form x plus y plus z equal to 1000. But if you don't know 1000, then you can take the right hand side for such equation equal to 1. So all in all, to get steady state market share, you don't need to know initial market share, previous market share, because here as you have taken XYZ, on the right hand side there is XYZ again. So all in all, steady state depends on transition probability matrix. So for a given transition probability matrix, steady state is fixed. But when that steady state will be reached, is for finding that, you will have to continue doing these computations till you get this market share equal to this one. So getting period for reaching to steady state will not look at that part. Okay, but steady state is this one. Now that we come to know the steady state for a given transition probability matrix, what remains for us is if we are able to make certain changes in steady state in a transition probability matrix, our steady state will change. So for designing the strategies, for designing the courses of action to be taken for our benefit, what people do, they design their strategies. Like we are going to design one for this problem. So whenever you look at this through the exam point of view, you first may have to design the transition probability matrix. And once you are, the key thing which is very important here is design of transition probability matrix. In this case, it was very easy, but in some cases, we'll be seeing those. It won't be much difficult, but you will have to do some brain work to get a transition probability matrix. Once you get that, most of your problems are solved, and uh, you can do you can utilize this transition probability matrix uh, for predicting the market share for future periods, and also predicting the steady state market share. So we'll be doing certain analysis on this. Now we want to design the course of action or strategy for company A. Possible actions company A is thinking of is maintain status quo. Okay, let the things be the way those are, for which we have already found the steady state market share. Okay, and the second course of action, work for reducing the customers of company A losing to B and C to 1 by 6 each. Right now, the customers who are losing, customers of A losing to B and C are 1 by 5, 1 by 5 each. Instead, we want to reduce it. The out of 6 customers, one customer I can allow to lose. Okay, so I will be taking certain actions by which instead of losing one customer out of 5, I'll reduce it down to 6 customers out of one customer out of 6. Hmm? To B and to C. So what is going to happen? This 1 by 5 figure will reduce down to 1 by 6, and this also will reduce to 1 by 6. So 1 by 6 plus 1 by 6 will make it 2 by 6, and therefore the customers which are getting retained with A will be 4 by 6, because this total has to be 1. So that's what you are seeing here. So that this work for reducing the customers of company A losing to B and C to 1 by 6 each from 1 by 5. Okay, so that I have just explained to you. Customers of A losing to B and C were 1 by 5, 1 by 5 each. Here I made them 1 by 6, 1 by 6, and therefore this was changed to 4 by 6. No change occurred elsewhere. Okay, and then work for attracting half of the customers of B losing to C. Okay, so all these things are going to make some changes in the transition probability matrix. Like we have seen that this change, this course of action change this transition probability matrix to this one. Now, in what way work for attracting half of the customers of B losing to C? Now, let us find out how many customers are losing from B to C. Let's see. Customers losing from B to C are 4 by 6. From B to C, we are losing 4 by 6 customers. Okay. So, we have to attract half of these customers. which are losing from B to C. 4 by 6 means half of this will be 2 by 6. Okay, and this 2 by 6, company A will be gaining from B. So this figure, this will reduce down to 2 by 6, and that 2 customers out of 6 which we have saved from losing from B to C is attracted by B. So this will become 3 by 6 and this will remain to 2 by 6. 50% of this will be retained here and that 50% will be attracted here. So just based upon what that course of action is asking you to do, you do that kind of changes in this transition probability matrix, like 50% of these are attracted by A. Okay, B losing to C. Now B will be losing to A. That means A will be gaining from B 3 by 6 and B now will be losing to C 2 by 6. Total has to come 1. 3 by 6 plus 1 by 6 plus 2 by 6 will come 6 by 6 and that's 1. Okay. So that is how we have changed the transition probability matrix. And as I have told to you that the steady state market share is the function of transition probability matrix. So now once again talking on first course of action. The transition probability matrix was same and therefore we have found out steady state for that just by multiplying xyz to transition probability matrix and equating it to xyz and taking one more equation x plus y plus z equal to 1000 and solving this got us this market shares. X equal to 357.14, y equal to 214.28 and z equal to 428.57. Now this change market share, this change transition probability matrix. What we are going to do with that? XYZ multiplied by transition probability matrix is equal to XYZ and this equation in addition. Solving this three equations out of this four, I get the market composition as X equal to 400, Y equal to 200 and Z equal to 400. Now this transition probability matrix again I utilize for finding steady state market share. How do I do that? How do I do that? This XYZ multiplied by TPM is equal to XYZ and one more equation X plus Y plus Z equal to 1000. Solving three equations out of this four gets me the steady state market share. X is equal to 465, y equal to 209 and z equal to 325.58. Now by comparing for market shares for company A only because the strategies have been designed by company A. So company A will choose that course of action choosing which will result in maximum market share for company A in long run steady state. So here, by doing nothing, by maintaining status quo, the market share is 357. By second strategy, that is work for reducing the customers of company A losing to B and C. The steady state market share for company A is 400, and by attracting customers of B losing to C, the steady state market share is 465.11. Right, so this is maximum market share for company A, so this should be worked upon. Okay, plan third should be worked upon. So this is the way Markov chain analysis helps us in selecting the proper strategy. Because when we think of certain strategy out of this two, if we know where it is going to end, what is going to be the end result of each of the strategy, we will put in our energy in that particular strategy. So here we knew that this is going to give us maximum market share. That's why we will be putting our energy in plan 3. Okay, if say blindly I put in my energy in plan 2, I will end up getting market share of 400. So that is the power of Markov chain analysis. So all in all, by now you have understood that the transition probability matrix is the key of everything. Once you are having the power of designing the transition probability matrix for a given situation, then rest of the analysis is not difficult. You can easily do it. So key is getting transition probability matrix. So now we will be trying to get transition probability matrix in various situations. Okay. So here we go. We'll be seeing different situations wherein we will be forming transition probability matrix. First problem. Probability that the script price, share price, increased today is zero point 0.7 if it has increased yesterday, and zero point 0.2 if it has decreased yesterday. Now there are two possibilities, and there are 2 days of which the transition is being talked up. Okay, now it is script price. It may increase or it may decrease. Like it may increase. Up arrow is showing increase and down arrow is showing decrease. Okay, it may increase today, it may decrease today. Okay, and same thing may happen tomorrow as well. Okay, so these are the states today and these are the states tomorrow, right? So share price may increase tomorrow and share price may decrease tomorrow. No, it's not the story between today and tomorrow. It is the story between yesterday and today. So this was the state yesterday and this is going to be the state today. Now we know that the probability that the share price will increase today, this is today, increase today, if it has increased yesterday is zero point 0.7, right? So zero point 0.7 must be written here, okay? And if the probability of increase in the share price today is zero point 0.7, then the probability of decrease in the share price today it will be 0.3. Now, what happens if the share price has decreased yesterday? What is the probability that it will increase today? It is zero point 0.2, that is given. It has decreased yesterday, then the probability of its increasing today is zero point 0.2. Okay, and decreasing today will be zero point 0.8 obviously. So this was very simple example wherein we have formed the transition probability matrix. For forming the transition probability matrix, one thing you have to remember, what states you write here, same states should be written here as well. Okay, and once you come to know number of states involved in the problem and actual designations or values or variables of the state, if you come to know, you write them here, and then this matrix is to be filled in by proper probabilities. Okay, now same problem expanded on 3 days. Okay, probability that the script price increase tomorrow, probability that the script price will increase tomorrow is zero point 0.7 if it was increased today and yesterday. Okay, if it increased here, I'm sorry, it is written was, okay, a little bit grammatically incorrect. Zero point 0.7 if it increased yesterday, today and yesterday. Okay, right? Zero point 0.7 if it increased today and yesterday. Zero point 0.6 if it increased, it has increased today but was low yesterday. Okay. Zero point 0.5 if it has been low today and high yesterday, and zero point 0.3 if it was low today and yesterday. Now this implies that there are 4 states, right? Share price yesterday and today. This I am going to change with today and tomorrow. Okay, this is some skillful job when you see how to design transition probability matrix for 3 4 problems. Then it won't be much difficult for you to design transition probability matrix for any new problem. Okay, so there are two things happening which is compared with one thing happening tomorrow. Okay, two things happening, one thing is happening today and another thing is happening yesterday. Okay, let the first arrow is signifying the happening yesterday and second thing is signifying the happening today. Now, as I said, that whatever you write here, you have to write same thing here. But as far as the details given in the problem are concerned, there is a mention of tomorrow only. So what I can do to make this state similar to this states, I can change tomorrow with today. Okay, tomorrow with today. So for tomorrow, today will be yesterday. Okay, so again, it will be the story being talked about today and yesterday only. Okay, this thing you think of, spend your time on thinking on what will be today for tomorrow. It will be yesterday. When you go into tomorrow, tomorrow will become today and today will become yesterday. So ultimately we are chaining the things today and yesterday with today and yesterday of tomorrow, right? So this is today and this is yesterday. So today increase and yesterday increase. Okay, today just the second is today and first is yesterday. Okay, yesterday increase and today increase, yesterday increase and today decrease, yesterday decrease and today increase, yesterday decrease and today decrease. Now what are these? The first is today and second is tomorrow. Today increase, tomorrow increase, today increase, tomorrow decrease, today decrease, tomorrow increase, and today and tomorrow both decrease. Once having written this and understood this properly, we have to fill in the values. Now point 7 is the probability of the script price increasing tomorrow if it has increased today and yesterday. So today and yesterday means this one. Okay, and this first is today. Today increase has to be coupled with this today, then only you can write the information here. This will be the probability of increasing the script price tomorrow. Okay, today increase is implied here itself. Okay, so this has to be changed with this, and the probability of increasing the script price tomorrow is zero point 0.7 if it has increased today and yesterday. 0.7. So probability of decreasing the share price tomorrow will be zero point 0.3 because increase in the script price today, the probability of it is zero point 0.7 provided it has increased today and yesterday. Here I am writing 0 because it is talking about decrease in the share price today, just low arrow, whereas the share price, we are not referring to decrease in the share price today. So here the probabilities are going to be 0. Okay. Then the probability of increase in the share price tomorrow is zero point 0.6 if it has increased today. Increase today means this. Third row now. Increased today and decreased yesterday. It was low yesterday. So I have to write the things in third row, but you make sure that it is written in the column where the first arrow is up arrow. Okay, first arrow is up arrow because we are talking about increase in the share price today. Okay, the probability of increase in the share price is zero point 0.6, and therefore the decrease in the share price tomorrow will be zero point 0.4. So second arrow decrease, first arrow essentially must be increase. Okay, and now here again the values are 0 because they are referring to the share price decreasing today. whereas the share price is not decreasing today. We are talking about share price increasing today. So in the columns which are related with share price decreasing today, you have to write 0. Now third row, what is it referring to? Low today and high yesterday. This is talking about this is high yesterday and low today. Okay, so the values are to be written. Values are to be written where the today arrow is in low, here and here. Today arrow is in low, right? And the probability of increasing is being talked. The probability of increase in tomorrow's share price is zero point 0.5, and therefore decrease in tomorrow's share price will be zero point 0.5 again. And lastly, mm, zero point 0.3, if it was low yesterday, and zero point 0.3 if it was low today and yesterday. So I have to write the values where the share price values are indicated to be low today, low yesterday, and low today. So in fourth row I have to write. Okay. Again, I have to write them in the column where the share price decrease is referred. Decrease today is referred. So this is share price decrease today. This is share price decrease today, right? So probability of increase in the share price tomorrow is zero point 0.3. So here zero point 0.3 is written, and therefore zero point 0.7 is written here, and elsewhere it is written 0. Okay, by sparing your time once again on this problem, you will understand this very clearly. Now coming on to the third problem. Okay, player has to leave the game if he wins rupees 300 or lose everything. That means he doesn't have money. In every game, the amount with him changes by rupees 100. Means he wins 100 or he lose 100. Okay, so money either will get added by 100 or subtracted by 100. Okay, so um, for the player, probability of winning is zero point 0.7. So first of all, you have to decide what are the states. Okay, the states would be the player will be having 0 rupees, 100 rupees, 200 rupees, and 300 rupees. Okay, here because I have written those values, so it was not much difficult for you to think of what will be the states. Okay, but it will be better if you are able to write these states yourself. Okay, the player will be having this much of amount um, after game. Okay, and this much amount once again. Now if player had 0 rupees, that means he will have 0 rupee at the end of the game, because he is not allowed to play. Okay, so zero state will continue to be in zero. He won't be, he is not allowed to play, so there is no question of him earning 100, 200, or 300. Here the probability that zero, the probability that zero will return to zero is 1, sure. Okay, and likewise, the player who wins rupees 300 has to leave the game. Okay, so 300 state will continue to be in the state of 300 because he has to leave the game. Okay, so the probability of 300 returning to 300 is 1. 300 cannot drop down to 200 or 100 or 0. Now, suppose say the player has 100 rupees, right? What is the probability that that amount will become 0? Because the player is expert player and he wins often, 70% of the time he wins. So 100 will convert to 200. The probability of that is zero point 0.7. 100 won't remain 100 because he is playing. Okay, and there is no draw concept. and 100 will become 0, the probability of that obviously will be 0.3. 100 cannot become 300 in the next game, right? So here again 0. Now if the player has 200 rupees, if the player has 200 rupees, then the probability of 200 becoming 0 is 0. 200 becoming 100 will be zero point 0.3, because if he lose, he will be reducing his amount from 200 to 100. 200 to 200, again the probability is 0, and 200 to 300 probability is zero point 0.7. This is the way you write the transition probability matrix. Alright, so coming on to the next problem, and that probably uh, is the last but one problem. Alright, coming on to the next problem, right? A retailer pharmacist has a policy of checking the stock of BP monitors on Saturday, and to order three instruments if there is no instrument in stock. If there is zero instrument on the checking of the stock, review of the stock on Saturday, if the retailer finds that there is no stock of BP monitors instruments, then he will be ordering three instruments. Okay, weekly demand for instrument is random and follow Poisson distribution with a mean of one instrument per week. Order material arrives on Monday. On Saturday, he will be placing the order, and ordered material will arrive on Monday. Sunday is holiday. All right. So now, what are going to be the states? The states are relating to the number of cameras. Sorry, number of BP monitors. Right. Uh, there could be no monitors when he review the stock on Saturday. No monitors, right? Zero monitors. There could be one, there could be two, there could be three monitors when he review. And he in his review on next Saturday, the states could be same: zero monitor, one monitor, two or three monitors. Okay, now that I know the states, I have to fill in the matrix, 4 by 4 matrix. How the states change from 0 to 0 over a period of week. That is what is to be done. Now, here we are referring to Poisson's probability distribution. The demand for BP monitor follow Poisson distribution, right? Now, as it follow Poisson distribution, you know the formula for probability that the demand is x is given by lambda to the power x into e to the power minus lambda upon x factor. Okay. Now, the mean demand is 1. Value of lambda is 1. Therefore, the formula simplifies for us. And that is what? The 1 to the power anything is 1. E to the power minus 1 and x factorial. Okay. So probability that the demand is x is given by e to the power minus 1 upon x factorial. So our demand, as we know here, can be 0, can be 1, can be 2, can be 3, it can be even more than that. But we will be computing the demands for probability for these three demands only. By putting 0, 1, 2, 3 as a value of x in this formula, we get this probability. Now, how to fill this matrix is a question, right? Now, on Saturday, suppose say I had zero camera. What will I do? I will place the order. On Monday, I'll get three camera in my stock. Okay, so what is the probability that on Saturday, next Saturday, there won't be camera in the stock? Okay, all three cameras which I have purchased, which I got on Monday, will get sold, and that is possible only when there is demand for three or more cameras. Okay, probability that demand is greater than equal to 3. And how I find that? It is 1 minus probability that there is demand for 0, demand for 1, and demand for 2. That is what is that will give me the probability that the demand is greater than equal to 3. Okay, so 1 minus p0 minus p1 minus p2. Okay, total demand is 1, and when I want to find probability that the demand is greater than 3, that means I have to subtract from 1 demand for 0, demand for 1, and demand for 2, and that gets me 0.0803 by doing these calculations. And if I have 0 cameras on Saturday, 0 on Saturday is as good as having 3 on Monday. Okay, so what is the will it be possible that on next Saturday, when I review the see, I am using sometimes camera and sometimes BP monitors. Okay, sometimes BP monitors, right? So you just worry about it is some instrument, whether it be camera or BP monitor doesn't matters to you. Okay, so so you suppose say you had 0 camera on Saturday. That means on Monday of next week you are going to have 3. And what is the probability of having 1 on next Saturday? That means exactly 2 cameras should get sold. The probability of exactly selling 2 camera is 0.18394, right? Then um, the probability uh, from 3 to getting converted to 2, all right? That means exactly when I have 0 camera on Saturday, it will get converted to 3 on Monday. And for getting 2 cameras on Saturday, next Saturday, I have to sell exactly 1. And the probability of selling exactly 1 is, that means there must be demand for 1. Okay, so 0.367879. And for having exactly 3 camera on next Saturday, 0 camera, there should be demand for 0, and the probability for 0 demand is 0.367879. Okay, now coming on to this next story. Suppose say on this Saturday I had 1 camera in stock. So I'm not going to order on Monday. I'm going to have 1 camera only. Now, how I will be having 0 camera on next Saturday? That means there must be demand for 1 or more camera. Okay, there must be demand for 1 or more camera. That is probability that the demand is greater than 1. And what is that probability? 1 minus p0. 1 minus p0 will get you this. 1 camera will be converted to 1 camera on next Saturday. That means there must not be demand during the next week, and the probability for no demand is 0.367879. 1 camera cannot be converted to 2 and 3 camera next week. Okay, so probability is 0. Now suppose say I have 2 cameras on Saturday this week. How I will be having 0 camera on next Saturday? Okay, that means there must be demand for 2 or more cameras. Okay, probability that the demand is there for 2 or more cameras. What is that? 1 minus p0 minus this is p1. Okay, I have made a mistake here. Okay, which I will not be correcting right now. Can I? Just a minute. Just a minute. Let me do that correction. It's going to take a time. You better do that correction. All right. So it is 1 minus P0 minus P1 will get you this value 0.262 and how two camera will get converted to one camera next week. There must be demand for one camera and the probability for that is 0.367879. Two camera remaining two camera next week, that means there must not be demand. The probability for that is again the same, and two cameras cannot get converted to three cameras, so probability for that is zero. All right. And having three camera on Saturday is as good as having zero camera on Saturday, because these are going to get converted to three camera at the beginning of next week. So this row will be similar to this row. All right. This is how from this story, from this explanation, we are able to form the transition probability matrix. And lastly, one last problem. Okay, attendance for the students for a student for 25 days is as follows. Okay, p p p a a p a p p p a a a a p. Then in fourth week he was all present. In fifth week a p a p p. Now what we are going to, we have to form the transition probability matrix, right? And what are going to be the states? States are the student is either present or absent. Okay, so he is present or absent. Now how the transition will take place? There are four possibilities of transition taking place. P to P means previous day he was present, next day also he is present, then previous day he is present, next day he is absent, previous day he is absent, next day he is present, previous day he is absent, and next day he is absent. There are four possibilities, so we are making a count. P to P. So here is one, then P to P second, and then third, then fourth, then fifth, sixth, seventh, eighth, ninth, and tenth. There are 10 transitions from P to P. Likewise, you count the transitions from P to A. Here is one, two, then P to A, three transitions from P to A. Then A to P, here is one, and then second, then third, then fourth, and then fifth, five transition. And from A to A, here is one, then two, then three, then four. Four transitions are there. Okay, right? So from P to either P or A, there are 13 transitions. Okay, there are 13 transitions from P to P or A, and from A to P or A, there are 8 transitions. Okay, right? There are 9 transitions, right? Total. So what do you do? So P to P now. You just P to P will be 10 out of 13 and P to A will be 3 out of 13. Then from A to P and A to A, there are total 9 transitions. So A to P will be 5 by 9, A to A will be 4 by 9. Right? So we'll be stopping here for some time. Um, right? And then let's finish this. This is the last problem and a very simple one. This is a mouse maze problem, right? Say there are 12 rooms and the mouse is moving from one room to another, right? From every room to every other room, mouse can move, right? So there are how many rooms? 12 rooms as we are seeing, from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right. So the mouse state will change from 1 to 12 to 1 to 12. So this will be 12 by 12 transition probability matrix, right? So this mouse, if he is in room number one, he can go to two or he can go to four, because there is some opening here and here. He can go from one to two, one to four. So one to two, the probability is equal of going to two and of going to four. One by two and one by four here. Okay, and if he is in room two, the mouse can go to one, go to three, and go to five. So equal probability, it will be from two to one, one by three, two to three, one by three, and two to five, one by three again. Okay, this way, by just counting the number of rooms in vicinity, you can find out, fill up this transition probability matrix. Just look here, if the mouse comes in room number 11, this is the exit. There are three exit doors. These are not actually the rooms: 10, 11, and 12. Okay, 10, 11, and 12 are exit doors. So from 10, it will continue to be out in the state of 10. Hmm. So probability is 1. From 11, if the mouse comes out from 11, he will be still in the state 11. And if the mouse comes out from the door of 9, okay, if he is in state 12, the mouse will be in state 12. All right. So this way, these are called as absorbing state. Absorbing state means once the mouse has came into that state, he will continue to be in that state. This is how you will be forming the transition probability matrix. So here we finish some our discussion on introductory concepts of Markov chain analysis. You already know how to utilize this transition probability matrix for getting the composition of future states and steady state composition of the states. Okay, you can find out many applications in predicting these states and finding the steady state, the strategy designing, etc. of this Markov chain analysis. So here we stop. Thank you very much.